Okay, here we are in chapter 9. So, chapter 9 begins um, teaching the hypothesis test. Um, all of the future chapters that are going to come will be doing hypothesis testing. So, we're going to be using the same steps to conducting a hypothesis test as we're going to be learning here in chapter 9 in future chapters. Um, and chapter 9 is broken up into 5 different sections. The first four are just to kind of describe the different parts of a full hypothesis test. A hypothesis test is like a multi-step procedure in order to conduct a complete hypothesis test. So again, the first 4 sections are talking about each of these different parts. The last section, 9.5, is about doing a hypothesis test from start to finish with all of the components built into it. Um, so, these are all the different sections. Um, and we'll be doing hypothesis testing about single population means and single population proportions. And that's a spelling error. Let me fix that really quick. Okay. Um, so in statistics, one wants to make statistical inferences about populations based on samples taken from the population. So this is in contrast, statistical inference is different than maybe descriptive statistics. Descriptive statistics are what we've pretty much learned so far. So you take a sample and you get the sample mean. You get the sample standard deviation. Um, those are a couple of examples of descriptive statistics. They're just kind of quick numbers that you can calculate, which kind of give you some information about your sample. Now, let's look at this definition now of what we mean by statistical inference and how it applies to populations based off of information we get from samples. So previously, confidence intervals were used to estimate a population parameter. So the population parameters that we looked at specifically were the population mean and the population proportion. And so we created confidence intervals to estimate a population parameter with a desired confidence level. So for example, we would say that the population mean lies within this confidence interval with a 95% confidence level. Or when we studied the population proportion, we created a confidence interval that contained that population proportion within a certain confidence level. But remember, one creates a confidence interval. The created confidence interval has a confidence level percent chance of containing the true population parameter. So the type of statements that confidence intervals address are these. What is the mean rainfall per year in Brentwood, California, with a 95% confidence level? What is the mean number of chocolate chips in a bag of cookies with a 95% confidence level? What is the proportion of voters who will vote for candidate A with a 95% confidence level? So you can see what we're looking for is we're looking for, a population mean. We're looking for a population mean. We're looking for a population proportion. So these statements are questions to get ballpark values for the actual population parameter we are interested in. Now, another type of statement to address is to address a claim or to address an assumption. So if we were going to take these same topics but make a claim about them, we would say something like, the mean rainfall per year in Brentwood, California is equal to 25 inches. So here we're making a claim that the mean rainfall is a certain number. Previously, when we looked up here, we were just saying, what is the mean rainfall? We're not even giving a number. Instead, what we're doing is we're providing an interval or a range of values that it is. Here, we're making a claim that the mean rainfall per year is exactly 25 inches. Okay, that's a different approach. Another example is we looked at the mean number of chocolate chips in a bag of cookies. We're creating a range of numbers that hopefully would encapsulate the actual population mean of chocolate chips in cookies. But here we're going to make a claim. The mean number of chocolate chips in a bag of cookies is less than 1,000. So is less than 1,000. We're making a claim about the number of chocolate chips in these cookies. Another example is the proportion of voters who will vote for candidate A is less than 60%. Okay, so we're making a claim about what the true population proportion is, that it's going to be less than a certain number. So, hopefully with these examples, you can differentiate between these being a claim and these basically just being ballpark questions. Okay, so these statements are claims about the population. Claims are just assumptions, and claims need to be tested for validity. So how does one draw conclusions about a population based on incomplete sample evidence under the uncertainty present in real life? And the answer is, you begin by asking a question, making a claim, and conducting a hypothesis test. All right, now the next 2 pages are 2 different ways of looking at, conducting a hypothesis test from beginning to end. So this is more of a flow chart. This is what we call a graphic organizer, but this is a flow chart of the different steps that are involved in conducting a hypothesis test. So for some of you, this might make more sense, but it can look a little chaotic and a little unruly because it's not necessarily easy to follow as far as going from top to bottom, okay? But I've made those exact same steps, but now listed top to bottom in a more literal sense. Step 1, step 2, step 3, step 4, step 5. Okay, these are the same steps that you see up here in this graphic organizer. Step 1, step 2, step 3, step 4, and step 5. But let me use this graphic organizer really quick to kind of show you maybe the things that you've learned already. All right, so you can see what I've got boxed in here at the top. So when you're given a word problem, you're going to have this information from the start. So you'll be given some information about the sample. Okay, we've seen that in some of the problems and examples we've worked on so far. You may also be given some information about the population. So you're going to want to keep your eye out for that. So you're going to want to look at what information are you getting about the population? What information are you being given about the sample that was collected? Okay, and now what you've seen already is you've learned about confidence level and significance level. And so that will also be given to you. Okay, this is stuff that you learned in chapter 6 and in chapter 7, and you applied in chapter 8 when you made confidence intervals. Now, what we looked at specifically in these chapters, we were looking at the area under the curve. Okay. Um, and you learned that the area under the curve is the confidence level and the significance level. There's going to be a new area that you're going to learn about, and that's called the p-value. So we're going to learn about that, here in chapter 9. But the p-value is going to end up being compared with the significance level. Okay, we're going to be comparing two areas, like with like, during this hypothesis test process. Now, because we're dealing with hypothesis testing, you're going to keep your eye out for some claim that's being made. So you want to look for the original claim. What's the claim being made in the problem? And based off of this information that you've been given, you're going to determine what type of hypothesis test you're actually conducting. So all of these givens are going to play into the type of test you need to apply. And the type of test you need to apply is kind of the backbone as far as how you're going to proceed forward. This other information, the claim, that's going to kind of come into play later in this backbone of processes that procedures you're going to be conducting. The confidence level and the significance level and the critical value you calculate, that's going to come into play during the backbone of this hypothesis test that you're going to be doing in like a multiple step process here. So that's going to factor into it. One thing you've also already have learned is you've already looked at, here in chapter 12, we looked at, I didn't write it in here, but you calculated an R critical value. And this R critical value in chapter 12, that kind of told you, how you could interpret the line of regression, if it was a good estimator or a bad estimator. And so you look to see if your sample R critical, or your sample correlation coefficient, how that compared to the critical value. And that told you whether it was a good estimator or a bad estimator. So this process of comparing your sample correlation coefficient to a critical value correlation coefficient is a very similar thing that you're going to be doing here in this process. So that was the reason why I also put chapter 12 ahead of chapter 9, was to kind of introduce this idea of taking a parameter, or sorry, to take a statistic from your sample and compare it to a critical value and then make a judgment. That's what we're going to be doing here in this step. And if you remember, we did all of this on a number line. So, we had a number line here where we had -1, +1, and 0. And then we had our critical value. We had a positive R critical value and a negative R critical value. And that kind of separated good on these sides and bad in between. And then you look to see what your sample correlation coefficient, on which side of these boundaries it fell. That's what you're going to be doing here in this step. So you've already kind of been introduced to a lot of these ideas. You've been introduced to what a normal distribution looks like and a student's t distribution. You've already learned about that. You know about distributions being left-tailed or right-tailed or two-tailed, right? We dealt with two-tailed distributions in chapter 8 when we constructed confidence intervals. You kind of surreptitiously dealt with a two-tailed distribution here with this R critical value that we did. What's going to be new in chapter 9 is developing our null and our alternate hypotheses and determining whether we're going to reject or fail to reject that hypothesis. And from that, we're going to end up drawing a conclusion. And the conclusion is going to get composed from this conclusion table that you'll have available to you. So a lot of the components to a hypothesis test you've already learned, but you've learned them in, kind of independently and used independently of each other. But now we're going to be kind of sewing all of these different components together and adding just a few more components and stitching those together in a sequence in order to complete this 5-step process in order to come to a conclusion about our claim at the end. So, you're starting this with making some claim. You're putting it through a series of validity tests, and then you're coming up with a conclusion at the end. And that, in a nutshell, is what a hypothesis test is about. So I've prepared these 2 pages back to back. Hopefully they print it out, on one page so that it could be taken out and it could be placed in front of you. So you can use it as a guide to kind of help you through this 5-step process until it becomes something that you've learned and that you can do without that help. Consider these, this graphic organizer and this listing of the steps is kind of like training wheels. So there'll come a point when you can take the training wheels off and you won't need, to look at these steps anymore. You'll kind of already know what the steps are. And these same steps are the same steps you're going to apply in chapter 10, chapter 11, and in chapter 13. Okay. You'll just be making tweaks within a step. Okay. So I think that's a good point to stop here, and we'll go into the next section here. All right. Let me know if you have any questions.